Today we're going to talk about a brain teaser problem. So the problem is given a right triangle with sides 45, 60, and 75. If we randomly put a dot inside the rectangle, inside the triangle uniformly, then what is the average sum of distances to the three sides? So, for example, if this is the dot we put, the sum of the distance will be the dot to the y-axis, which is x, and the dot to the y and to the x-axis, which is y, and the dot to the slope, which is h. So we want to find the average value of x plus y plus h. So if you look at this problem, if for fixed x, the y is also uniform. It's uniform from 0 to a maximum point that when we reach the slope. And same for y. Same for x. If y is fixed, then the value of x is between 0 and the point here on the slope as well. So what we can do is that we can find this range for y and x. For y, we can see that y is so that's proportional. The side from here. So let's say y is here. This y is the maximum for the on the y-axis. Then the distance from here to y versus the distance of the whole length 60 is equal to x versus the length of on the base side. So that gives us 60 minus y, which is this length, divided by 60 is equal to x is equal to x divided by 45, and that will give us the value y. And similarly, we can find the maximum point here for x using the same method. So that will be 45 minus x divided by 45 is equal to y, which is this length, divided by 60, and that will give us the maximum value for x when y is fixed. And both y and x, when given a condition of the other variable is fixed, itself will be a uniform random variable, and that will give us the conditional random variable y given x, which is so y, conditional random variable y given x, that will be uniform from 0 to the maximum point here, which is 60 minus 4 over 3x, which we get from here. And same for x given y, which is also uniform from 0 to 45 minus 3 over 4y, which came from here. And from here we know that the conditional PDF for y given x is 1 over the range of the uniform. The conditional for x given y is 1 over the range of the maximum value of this uniform. So now to find the value for expected value of x plus y plus h, we need to find three things. One, what is the expected value of x? Second, what is the expected value of y? And what is the expected value of h? So let's first find expected value of y and x. Expected value of y is equal to expected value of y given x, which is a formula we usually see in the probability theory. And that will be, we first take the first expected value inside the expected value, that will be the 1/2 of the range. And then by linearity of the expected value, we get 30 minus 2 over 3 expected value x. So expected value of y is a linear function of expected value of x. And same method, expected value of x is expected value of expected value of x given y, and that will give us a 1/2 of this range, and that will be 4 to 5 divided by 2 minus 3 over a expected value of y. The expected value of x in another way give expected is a linear function of expected value of y, and these two equations we can find expected value of y is 20. And similarly, we place the value into one of these equations will give us expected value of x, which is 15. And now we know the expected value of y and x. There's one more thing we don't know is the length of h. So to know what is the length of h, we know x, we know y. The h, if we look at this triangle, this right triangle, we know that we can separate this triangle into 3 smaller triangles from the star to the three sides of this triangle. Then if we look at this triangle, we say that this S1, then S1 is x is 45 times y divided by 2. And if we look at this triangle, let's call it S2, then this S2 is 60 times x divided by 2. And this triangle, the last triangle, is 75 times h divided by 2. And we know that the entire triangle is 45 times 60 divided by 2. And entire triangle equals the sum of 3 smaller triangles. And by doing that, we can find that h is a linear function of x and y. And we already know the expected value of x and expected value of y, then we can find expected value of x plus y plus h, which is eventually will be a linear function, will be expected value of 1/5 of x plus expected value of 2/5 of y plus 36, and plug in the expected value of expected value of y and expected value of x, we get the average value of x plus y plus h is 47. And so that's our answer. Another way of looking at this problem is that you see this is a triangle, and because the dot is this is uniform distributed, then this any dot in this triangle should be equally likely on any point inside this triangle. So the joint PDF of x and y is like this. So we have a base area, which is the area of the triangle, and the height will be 1 over s, which will give us the probability density function in 2-dimensional of x and y. And so that gives us expected the PDF of the joint PDF of x and y is 1 over the area of the triangle, given the condition that x is greater than or equal to 0, less than or equal to 45, and y is greater than or equal to 0 to the maximum point when x is fixed. That's what we found in here. So that's the joint PDF of x and y, and with that and with what we have known in here, the conditional PDF, and using Bayesian rule, we can find the marginal PDF of fx of x and fy of y. That will be the joint PDF divided by the conditional PDF of y given x, and that will be this. And you can verify that integrating this goes to 1. Same for the marginal PDF of y, which is this form with this constraint, and it can be also verified that this is a PDF. And that's it. So that's the solution of this question. And the next video we're gonna try to verify this result using Monte Carlo simulation in C++. Hope you like it.